Okay, my name is Simon Gould. I'm a journalist here at the Bauma News, the Daily News. Welcome to Bauma, where we're broadcasting live from the MOBA stand. Today we've got a panel of experts involved and around the road construction industry. Firstly, I'm going to get each one to introduce themselves.
My name is Michael Schreckenberg. I'm a professor at the University of Duisburg-Essen. I'm a theoretical physicist, and I'm working since 20 years on traffic jams and understanding why they occur.
My name is Alfons Horn. I am responsible for development in MOBA, inside MOBA. I'm working for MOBA since 30 years, and we have altogether inside MOBA 40 years of experience in asphalt, building road and asphalt technologies.
My name is Martin Muschalla, and I'm project director working for the TPR. It's a material technology competence center within one of the largest Europe road construction groups, the Strabag SE, as an independent technology laboratorium.
My name is Alfred Ulrich. I'm professor in Cologne on a university, and my job is construction, building machine, and heavy machines, etc.
So welcome to a big welcome to all our experts. I think that we'll start off the forum with what everybody's pet hate, the issues relating to traffic jams. So we'll pass you over here and give us a bit of background information on how we can resolve the issue.
Traffic dynamics is everywhere around the world the same, and the occurrence of traffic jams also. We have a certain percentage of traffic jams which occur only due to human behavior. That is, we could have 20% less if the people would optimize their behavior. So normal dynamics is the following: we have free flow traffic, and then if it becomes denser, the people slow down to 10 to 30 kilometers per hour. That is in regions where we have high population, where we have many on-ramps, and after that, if one of the drivers stops, really speed zero, and others have to stop also due to this driver, then we get a jam wave, and this will turn back with about 15 kilometers per hour. That is unique all around the world. And this survives as long as enough cars come from behind. And on top of the jam, the people accelerate with the distance about 2 seconds. So see, then the traffic wave can become bigger, or it can become smaller after the rush hour. But this can move now along the roads. It can turn to another highway. It can turn into cities, and if you then meet this traffic jam wave, you don't know why it is there. So the people then say that it's a jam out of the blue, from nowhere, as we say in Germany, aus dem Nichts. And this is about, say, 50-60% of all jams. The other ones are due to roadworks, due to accidents, due to weather conditions, and this is mainly true for highways. In cities we have different reasons for that. There's parking cars on the roads, and we have normally the traffic dynamics due to the intersections, the traffic signals, traffic lights, and that is the main problem, to optimize this. But we can also optimize the flow even in regions where we have road works, where the lanes become smaller, and where the people have to be very careful about what they do.
So, MOBA has been involved in road construction for many decades now. Just as a segue to the project that we're going to talk about, can you give just a bit of background as to MOBA's role working with the experts here?
Yeah, of course. As we already have mentioned, we are in this business for 40 years now, and asphalt road quality is always a subject. And this also belongs a little bit to traffic jams, because at least one part to reduce traffic jams is to produce higher quality roads. I mean, this is our main mission, this is our main idea, what we would really like to do in the future to produce higher quality roads. And therefore, we need to analyze, and this is very, very important, we need to analyze which parameters reduces the road quality. And that was the main part of the past project, which we already finished. And here we found out various applications, various technologies which should be implemented into our construction machines in order to improve the asphalt road quality. So that was the main intention of this research project. Mm-hmm. And Professor Ulrich, he is the one who really pushes this project, who brought everybody together on the table, where we have had these discussions, where we formed the team, which is always very, very important to have the right team, together with company Kirchner.
Die Grundidee war, die Probleme, die wir im Straßenbau haben und die im Grunde zu einer Beeinträchtigung der Qualität geführt haben und immer noch führen, ließen sich in circa 30 Module, 30 Strukturen, in der Struktur mit 30 Modulen darstellen. Und die haben wir gewichtet und sind zu 15 Modulen gekommen, wo wir gesagt haben, wenn wir die lösen, lösen wir ein riesengroßes Problem beim Bau von Asphaltstraßen. Und das haben wir mit einer Expertengruppe gemacht, wo alle Beteiligten, die dazu einen Beitrag leisten, von der Mischanlage bis hin zum Walzenfahrer, diese Prozesskette abgebildet und haben dazu die entsprechenden Experten uns geholt und haben daraus ein Forschungsprojekt definiert. Grundsätzlich kann man eins sagen, bei fast allen der beteiligten Maschinen in diesem Prozess fehlt das Verständnis in der Ingenieurwissenschaft zwischen Baustoff und Arbeitsgerät. Das ist eine riesengroße Lücke und dadurch gibt es viele Fehler in der Anwendung, aber auch bei der Konstruktion, Entwicklung von solchen Maschinen. Und der Facharbeiter draußen, der immer sein Bestes will, ist an manchen Stellen absolut überfordert und hat keine Chance. Weil, fragen Sie mal Ingenieure mit dem, was sie da konstruieren und was sie machen, ob sie wissen, derjenige, der diese Komponente kauft, wie der damit sein Geld verdient. Wenn man das weiß, weiß man, was man für den Kunden im Grunde entwickeln muss. Und hier gibt es ein riesengroßes Potenzial und alle diese Problematiken führen im Grunde zu einer nicht aus bestimmten Bereichen, einer nicht ausreichenden Qualität, die wir verbessern können und die wir mit PAST verbessern. Wir haben daraus geprägt einen Satz, der heißt, wir stellen nicht nur fest, sondern wir stellen ab. Damit möchte ich mich nicht mit fremden Federn schmücken. Der Herr ist hier nicht dabei. Der kommt von auch von der Firma Kirchner, einem Willi Dietrich, der ganz maßgeblich an diesen Vorhaben mitgepusht hat. So, okay, das vielleicht erstmal zu der ersten Frage.
Thank you. And can you just give me some background or give the viewers some background as to your role within the project?
Yes, something what we do in the project was to find out the problems, and road construction is a very extensive process, and the problem is that the various parts in the process are not communicate with each other. The paver does not know what about the asphalting plant and the material logistic, and that is the problem that this communication you need to make a process safety. That is what the finish of the project passed.
Mm-hmm. Right. Okay. And all of that said, how do you see the sort of processes and outcomes from the project enhancing tomorrow's roadways in big cities?
We will see in the future many things which are then responsible for the occurrence of jams due to human behavior. So one thing is that the road surface must be in such a way that the people can move safely. So that you see today that in many cases this is not given. And what we want is that the people use intelligent systems, not only have them in their cars, but are also connected to the others. And this is a very interesting project, wireless LAN. There you can then communicate with the other driver, telling you what happens in front of you. Maybe you have jams there, you know it in front. And on the other hand, you can communicate with the infrastructure. The speed is allowed and all these things. At some time today is that the cars have too much electronic devices on board, so you don't know where to look at. And you should drive at the end and not watch on all these instruments you have on board. So simple things installed on the road, and then the main thing is that traffic becomes safer. And that is the main goal. And we have many roadworks in the near future in Germany. So this is a very interesting thing to make these things easier and that the people understand what happens there, and then they will follow the routes.
So, as a supplier of technology to the road construction sector, where do you see it all going? How integrated are systems going to be, and the benefit to road construction?
Mm-hmm. Well, meanwhile, we have developed various sensors which analyzes the asphalt road quality. First of all, there is a temperature scanner which scans the temperature after the laying process, directly after the laying process. This is very important, and very often the specialists ask, why are you measuring the temperature after laying? It's too late. And then I always ask them, well, if you have a process, any kind of process, and you would like to optimize this process, what will you do first? What is the first step you do? And then he gives me the answer, well, I have to measure, quite clear. And the second step, I have to analyze. And the third step, I have to build up a loop, a control loop. And then I say, well, exactly, that's what we are doing. This is the first step. We measuring the temperature behind the paver. The second step, we analyze the data. And the third step, we build up a loop, a feedback loop, and control the temperature. That's the basic idea. So that also implements that the idea that in the future we would like to do much more. We already introduced in this research project a thickness measurement system where we measure continuously and in real time the thickness. Another subject is evenness. So we also introduced an evenness measurement system where we are able to improve the road evenness. You mentioned altogether 30 different parameters which could be observed, and of course we cannot do it at once. We have to do it step by step, but we start with the most important ones, which is again the temperature, the thickness, evenness, and compaction. So these are already products which we can see on our booth and which we will sell to the suppliers, to the OEMs.
Right.
Mm-hmm.
So, can I ask, with in road construction, if they get the asphalt mix wrong, it's too cold or too hot, what sort of financial impact can that have on the governments that are paying for these roads, you know, in terms of maintenance? And can you give us a bit of an idea there?
No, at first, you need the information, and that is the first problem what we have in road construction. And the benefit of the PAVE IR is that now you had the information about the temperature of the asphalt coating, and you can analyze after the project the temperature, and you see the problems, and then you can take higher the quality in road construction.
And back to the equipment supplier angle, how far away is a sort of complete seamless supply chain from asphalt to actually laying of the asphalt? I mean, that is obviously a direction that the industry needs to go in. How far away from that sort of are we in real term?
That's a good question. Everybody is asking me that because everybody really would like to have a complete system. Well, we have, as I mentioned before, we have our first product, but it's quite clear that a next step needs to be that we connect all these various measurements together. And within the past project, we already have at least some connections between temperature measurement system and a roller system, for example. Here we have to use WLAN communication, but it's not only WLAN, WLAN communication, it's also a direct interface to the internet. So the future is maybe like that we directly transfer all the process parameters which we measure directly onto a web server, and there, of course, we could, out of this data, we could generate a web page where everybody can see the road quality in real time. So that's our future goal. Of course, first of all, we need all these measurement system which analyzes, which measures the various process parameters. We, at the moment, in addition, we also provide on a roller a pass counting system, then a compaction measurement system, and a temperature measurement system. Of course, the compaction measurement system, we all agree, there's so many discussions about compaction measurement. It's for the experts, it's quite clear, it's not an absolute compaction measurement system. There you only get a tendency of the compaction, because a real compaction measurement system, I think that takes still another 10 years to have such a measurement system. But compaction, nevertheless, compaction is a very, very important process parameter, and we will work on this subject for sure. So at the moment, I would say within the next 2 years, we will have a first step which could be named as a complete system. But it will take us at least 2 years, from my point of view.
How willing are suppliers to the road construction sector? How willing are they to work with you, with the results that you found? Is it an open industry in terms of sharing of knowledge and experience?
Also wenn ich es richtig verstanden habe, das Zusammenarbeit mit der Industrie. Vorher möchte ich aber vielleicht auch einen Punkt mal zusammenfassen, der enorm wichtig ist. Die Philosophie, Qualität nicht nach der Arbeit zu prüfen, sondern Qualität bei der Arbeit anzuzeigen. Damit ermöglichen wir den Fachleuten wirklich mit der zur Verfügung stehenden Technik Qualität zu erzeugen. Und da wird häufig der Fehler gemacht, weil man das und jenes messen kann, dann messen wir das, aber das reicht nicht. Messen allein reicht eben halt nicht. Es muss an der richtigen Stelle gemessen werden und muss daraus die richtige Antwort gegeben werden. Und das heißt, zusammengefasst nochmal eins, und das ist wirklich eine Botschaft, Qualität bei der Arbeit anzuzeigen und nicht nach der Arbeit zu prüfen, um zu sagen, da warst du schlecht. Das ist eine, wie soll ich sagen, eine falsch verstandene Philosophie. Das war vielleicht mal die Erziehung zur Kaiser-Wilhelm-Zeiten und so wird teilweise auch noch gearbeitet. So, also da mehr Offenheit, auch mehr Mut. Was wir feststellen ist, dass uns dazu häufig die Messverfahren fehlen. Also wenn wir uns nicht vorstellen können von der Philosophie her, von der Fantasie, was ist an Messverfahren möglich, vorhanden, die wir anwenden könnten, dann, weil es zu schwierig ist, lassen wir es an die Seite und nehmen erstmal die Sachen, die wir so machen können. Aber das ist, wie soll ich sagen, nicht förderlich für die Zukunft. Und deswegen haben wir hier nach Past eine Sache gemacht. Wir sind am Ende der Einbaubohle, haben den Prozess bis dahin betrachtet. Die Straße ist damit nicht fertig. Die 8 Funktionen, die der Einbauprozess liefert, die wird beim letzten Walzübergang definiert. Beim letzten. Und das, was wir im Past-Projekt gemacht haben, wir haben die Welt davor so weit digitalisiert, dass wir jetzt, wenn es uns gelingt, diese 8 Funktionen bei der Walze zu messen, diesen Prozess dann oder diese Information, diesen Prozess davor zur Verfügung zu stellen, damit schon im Vorfeld das richtige Tun und Handeln an entsprechenden Stellen stattfindet. Und damit erreichen wir dann Folgendes: Qualität zu produzieren zu den geringstmöglichen Kosten bei Ausnutzung der Technik, die uns zur Verfügung steht. Und da muss ich sagen, da braucht man das Verständnis der Industrie. Wenn sie das hört, eine Vorstellung, damit Geld zu verdienen. Mit den Produkten, die sie dazu entwickeln, Geld zu verdienen. Und das gelingt nicht jedem Unternehmen, in diese Denke zu kommen. Da gibt es viel Berührungsängste. Ist immer, wenn was Neues ist, was es noch nicht gibt, dann gibt es immer Bedenkenträger. Und wir sind in einer Branche zu Hause, die ist geprägt von Bedenkenträgern. In jeder Prozesskette, in jedem Einzelnen gibt es da eine Menge von Bedenkenträgern. Und deswegen haben wir für dieses PAS-Projekt fast 8 Jahre gebraucht, um hier Fördermittel zu bekommen. Und jetzt sind wir dabei, das Nachfolgeprojekt Quast zu kreieren. Und ich kann Ihnen sagen, es wird nicht leichter. Aber wir werden es machen und das Ergebnis wird dann so ähnlich sein wie bei PAS. Und dann werden wir feststellen, dass wir weniger Staus haben, längere Standzeiten mit dem gleichen Material, nicht mit dem teuren. Die Kunst des Engineerings ist, mit weniger was besser zu machen, nicht mit viel was Normales zu machen. Das ist nicht unser Job hier.
Okay, so coming back to our pet hate traffic jams, how cities of the future, our cities of the future, how realistic is it to expect jams to be ever resolved? We're just interested in your comments.
Maybe at first I explain what jams cost. So this cost is enormous, and normally the drivers pay for it. So if you have a jam 4 kilometers long, 2 lanes during 3 hours, that is an economic loss of about 100,000 euro, one jam. So there are about billions, nobody knows about, how much is realistic, billions of euro every year within jams in Germany. So the people are staying in jams altogether more than 500,000 years per year in Germany. So you could work at that time and you could do other things. So it is very important to optimize the processes, that the roadworks become shorter, that you have less influence on the traffic flow. Normally one should also look during the works to optimize the traffic flow at the same time. There are many examples where the people didn't show, and it is also a question that accidents happen and this causes again jams and so on. So the optimization of these processes is very important, and I think many things have to be done. It is very interesting to see that one can formulate several modules which you can separate and look at them in a simple way, and to install them in the next step. That you don't do the whole thing in one step. And I think the people, if they understand what is going on, normally the people are very angry about roadworks. since they always say that they don't work and nothing happens and so on. So it's very important also to communicate with the people, to tell them we are doing better than before, we are doing everything we can, and also research is doing that what they can do in the future. So I think we can optimize many of these processes, and this is a very important first step, and the people will honorize it, and then with their behavior on the roads.
Good. Well, we're coming towards the end of our broadcast. I think we probably just have a bit of a summary from everybody. So if you just conclude it.
Yeah. My summary is that we are really on the right track, and that we, as a company, we really would like to continue the idea of improving the road quality. Once we made a very interesting calculation, if we can improve the lifetime of a road or extend the lifetime of the road by just 1 year, that means in the end 3 to 4, sometimes 5 billion euro cost saving in Europe. So it's a huge money which can be saved, and therefore it is necessary to improve this subject, to continue this road quality subject, and that's what we wanted to do in the future.
Yes, and I think to get always a high quality in road construction, it's important in research projects to finish the connection of the various parts in the process, and that you have an automation of the road constructions.
Ja, ich kann zusammenfassen, Fortschritt braucht Kooperation, Kooperation zwischen Wissenschaft und Industrie, und diese Kooperation kommt zustande. Deswegen sitzen wir auch hier am Stand MOBA. Wenn Firmen Philosophien haben, die etwas mehr über den Tellerrand hinausgehen wie das Tagesgeschäft. Das braucht man, dadurch wird Fortschritt geschaffen, und ja, ich kann nur sagen, besten Dank an die Firma MOBA, an die Firma Kirchner, dass sie der FH Köln die Möglichkeit gegeben hat, hier zusammen entwickeln, zu forschen, jungen Leuten die Chance zu geben, für die Zukunft was Richtiges zu machen. Das motiviert, und besten Dank.
Okay, so we have a question from Mr. Patel, who and I'll hand it to you, who asked the question: wouldn't a temporary solution to traffic be just to add more lanes? How much of an advantage is this process? What are the disadvantages
Of more lanes.
More lanes.
Okay, the question is, at any time in the history when traffic becomes higher, traffic demand, then you add a lane. This is true for some time, but in the future we will have less traffic by private cars, since the population is going down. So it is much more interesting to optimize traffic flow on the existing road network than to add anytime one lane, and you don't optimize the use of the road. So I think it is also a question of money. So in the future we have to repair so many roads that these processes have to be optimized, and not thinking about more and more roads. You see, now we have more or less a complete network. There are some missing links, but at the end the road network is for the traffic we have complete, and we should use it in an optimized way. You learned about what does it cost to add a lane, so it is much more interesting to use the road more intelligent, to be connected to the others. And if you have an optimal 2-lane road, it is much better than a non-optimal 3-lane road. So you should invest money in optimizing that what you have, and not adding and adding. That was the history, the strategy in the history for 50 years. But now we learned that we come to a limit, and you cannot add more lanes and more lanes. And you see in other nations it is such that the people are thinking about toll road pricing and all these things to have better roads, and then the traffic becomes safer and more optimal.
And just you're gonna close for us.
What?
So you're just going to. There's already been a summary there. So okay. So that's it. Thanks very much indeed for joining us at the forum. Hope you found it informative, and see you next time.